error, because you got margin of error. Error equals this. Don't worry about writing this down because I'll show you why. Error equals d of c times sigma divided by the square root of n. And there's going to be situations in this class where you're going to have to figure out a sample size that would fit for a certain margin of error. What I would do is I would solve for n. You don't need to worry about writing this down, but if I was solving for n, I'd multiply by the square root of n on both sides, and then square root of n times e. Then I divide by e, the margin of error. So the square root of n equals z of c times sigma divided by e. And then this is how you derive this formula. The sample size you need is the critical value times the standard deviation divided by the error squared. Okay. So this is not that hard. You don't have to know about worrying about this. I was proving to you how we get to that formula there. But this is not going to be hard, I promise you. So let's look at the situation. A wildlife study is designed to find the mean weight of salmon caught in the Alaskan Fishing Company. A preliminary study of a sample of 50 salmon. First off, now we're going to treat that like the population standard deviation here. Okay, we're going to have to put that in for sigma, even though it's from the sample. How large of a sample should be taken? So how large of a sample? They're wanting you to find how large, so n should be, to be 99% confident. 99% confidence would then help us find? Helps us find z of c. So z of c, sometimes they write it like this, z of 0.99. You go find the 99% confidence, 2.58. So 2.58. And then with that's the error. So within that margin of error, so within 0.2 pounds. So let me dumb it down for you. All you're doing is you're plugging this, and this into that formula, and you're calculating it. So n equals the critical value, which is 2.58, times the sigma, which is 2.15. So you're finding the things you need, the standard deviation, the critical value, and the error, and you're just plugging into that formula, okay? I promise you this is not that hard. 2.58 times 2.15 divided by 0.2. Now square this. 769.23. Now, one rule with confidence intervals, when I'm finding the sample size, what you have to do is if I round down, I'm technically not going to be within that margin of error. I'm going to be a little above it. So I have to round up. So I have to round up to the next one. So it'll be 770. You're supposed to round up. Now, they might do it wrong on the proper way to do it. The right way to do it is you round up. Okay, but I guess I put salmon there. Not that it matters, but you might run into a little bit of that on, hopefully no issues on this.